Okay, good morning, guys. This is 10.1, use properties of tangents. And the main concept today is we're working with circles. Okay, all right. So, a couple things about a circle before we get started here. In your notes, there's quite a bit of stuff up on the board here. I'll try to organize it the best I can, but we're pretty much going to make these two circles here in your notes. Almost wish I had a blank sheet here, but here's what things that you might have known before. If you have a circle and you have the center of the circle, the distance from the center to the outside of the circle is called the radius. The distance from one side of the circle to the other side of the circle going through the center, like so, is called the diameter. The diameter is twice as big as the radius. The next one would be a chord. A chord hits the circle. It has endpoints on the circle, but it doesn't go through the circle. This is an example of a chord. Two endpoints on the outside of the circle, and then it connects. And remember, this is called the center of the circle. Okay, so I'll erase here and I'll keep on going here. So I have a second circle ready to go. These are a few of them that are going to be brand new now. So if you have a circle, the definition of a tangent is it hits the outside of a circle, but just at one single point. So it'll just barely hit the circle. For example, here's a straight line that barely hits the circle. It's at one single point right there. That's called a tangent line, and the actual point is called a point of tangency right there. You could draw multiple tangent lines. For example, let's say you have a line that goes this way. It hits at one spot. This way hits at one spot. Now, I wouldn't draw all these in because it's going to mess up your notes, but you get the idea. You could pretty much draw an infinite amount of tangent lines. Again, where the point hits is called the point of tangency. The line itself is called a tangent line. Okay, so I'm going to clean this up a little bit. We'll go back and we'll draw that in again. So you had a circle. Here's the center. Here's your tangent line. Yeah, that's your point of tangency. Please draw that in right there. And then here's the next thing. A secant is a line that goes completely through the circle and hits twice. This is called a secant line. Right there. Chord stops. Secant goes through. Tangent hits the outside of the circle. This terminology is on the first quiz. It's on the beginning of the test, and I believe it's the first problem for today. Please draw this picture in. I know it's going to take some time, so just let whoever's showing you this video, let them know that you need to pause at various times throughout this video. Once you have that drawn in, our options are radius, chord, diameter, secant, or tangent. Now, what we want to do for our problems, we want to go AC, AB, DE with an arrowhead over the E, and then AE, and then we got arrowheads on both sides. So that's a line. So if you're looking at AC, it stops on A and stops at C. So from A to C, that would be a radius. Starts at A and goes to B, but it doesn't go through AB, it stops. So A to B, let's say here, all the way across, that's got to be a diameter.
Austin Hunt, do you have a message in your attendance office?
The ray from D to E. The ray from D to E is the line that's on the outside of the circle. It hits the circle on the outside. That's called a tangent line. When you get to the homework, even though it's not on here, actually we could put it on here, point B is the point of tangency. AE is a line that goes completely through, and I'm assuming that'd be your secant because it goes completely through. Yep. So get to know these well. It's not that they're free points on a quiz or test, but as long as you get your terminology down here, they're not too bad. Okay. Use the diagram to find the given lengths. The radius of A. This does not go into your notes, but please just watch as I do this. The radius goes from the center to the outside, so you just count 1, 2, 3. This has a radius of 3. The diameter of circle A. Since you hit 3 and 3, the diameter should be 6. Next one, the radius of B. You just count 1, 2. That has a radius of 2. The diameter of B, double it, come up with 4. Not too shabby for that one. Okay. The next one is coplanar circles, but what I'd like you to do is this. Give yourself a heading of coplanar circles. It just means two circles on the same sheet of paper or the same plane. And what are your options for drawing two circles? So if you randomly drew two circles on your paper and never made them cross like this, a circle over here and a circle over here, that would have no points of intersection. So let's organize our notes. So you have 3 columns just like they do. The one on the right, no points of intersection. The one in the middle, if you have 1 point of intersection, the 2 circles would hit right here. Or you'd have a circle inside a circle where they would hit, that's a bad drawing, but they would hit right there. The concentric circles actually looks like the target symbol. I'm sorry, I'm going back over here now, but there's a circle inside a circle. Never ever hits. That's 0 points of intersection. And the last one is if you have 2 circles and you cross them up, here's your 1, here's your second point, that has 2 points of intersection. Okay, your next heading is common tangents. So if you just think of common tangent, you know what a tangent line is. It hits a circle on the outside. So now this is talking like 2 circles. So how many different ways can you draw a common tangent? So don't put this in your notes. Just watch me as I draw them. So this one, it's drawn in for you. I'll just kind of highlight it here. That's 1. Now you could go the other way. Notice how it hits on the outsides of both circles. That'd be your second common tangent. Your third one would be on top here. Hit both circles. And the fourth one you could draw like so. So if you have 2 separate circles, you could draw 4 common tangents. And then they just kind of do the same thing. So one more time. On the outside, diagonal, diagonal, a total of 4 lines I drew. Okay, so now you have the heading common tangent, so let's actually put examples in. So you'll have 3 different examples. You can go A, B, and C. Separate them out. These first 2 circles are separate of each other, and it's going to look just like the previous page. Once you have those 2 circles drawn in, you're going to draw 1. See if I can get a little better. Or the board might just be that far off. 1, 2, and then the diagonals 3 and 4. This one's going to have 4 common tangents. Letter B is a little trickier, so the circles, they touch in the middle. You're going to have your outside 2, that's 1 and 2. And if they hit at a spot that's dead center, you draw your one that hits both of them. It's on the outsides of both, it just hits once, so that's going to be 3. And then your last one here. So letter C is when they interchange. There's no diagonal ones, there's just the 2 on the outside. So that's a 1, that's a 2, that has 2 common tangents. Now beneath this, if you want, let's see, if you want, we just get them all done. So you notice we have the 4, 3, 2, This is another example of the two. You don't have to put this one in. But if you'd like to add this one into your notes, not a bad idea. So you have a circle, and then you have another circle that's just a little bigger. Where can you draw it so it hits the circle on the outside, but hits both? Right there, guys. That would be your 1. And then your last one would be your circle inside your circle. There's no way you could draw it where they hit both circles on the outside. You'd be crossing in the inside of a circle. So this would be your 0. Okay. If you have a circle and a line of tangency, if you draw on the center to that point of tangency where it hits, always forms a 90-degree angle. This picture should be drawn into your notes, this guy right here. Now you can draw another tangent line somewhere else. Draw from the center to the point of tangency. There's another right angle right there. And you could keep on going. I mean, you can make as many as you wanted. But here's how it applies to the math problems for today. Okay, so find the line of tangency, and it is line ST. That hits the circle on the outside, like so. Point T is your point of tangency. So from the center to point T, that's your 90 degrees. That's supposed to be your 90 degrees. Now, to check to see if it actually is 90 degrees, you'd use a squared plus b squared equals c squared, where 37 is your c squared. $12 and $35 are your a and b. Do a little simplifying here. The left side equals the right side. This makes a right triangle, and it is a right angle. So that's just verifying that it's a right angle in there. Okay, and this next one. This is really, it's a tough one, but it's necessary that you get this one here and go ahead and draw this in. It's a really cool problem. If you are, I don't know if you guys know what a grain bin is, but it's a big circle or a big cylinder that holds grain. You can actually find how big the grain bin is without actually walking into the grain bin. If you could, and you know this is the radius, that's what you'd like to find. If you were standing on the outside, like out over here, and you just measured, I'll put a point there instead, and you measured to the grain bin, and then you took the tape measure and you went till it hit the side of it right here, and then you connected the point of tangency here, that'd make a right angle. So then we could use a squared plus b squared equals c squared, where we know this is the radius for both this line and this line. I could maybe make it a different color. So that's your radius and that's your radius. Well, if you measured 50 on this guy and 80 on this guy with your tape measure, we could find the radius. So here's what it would look like. So I am going to erase this drawing here and then start from scratch, because otherwise I'm going to run out of space for work. Okay, so if I redraw just the triangle and I start filling some things in, this was 80, this was r, and the hypotenuse was 50 plus r. It's the addition of 50 and r. Then we use a squared plus c, a squared plus b squared equals c squared. Let's start with our c squared. 50 plus r in parentheses squared. It's the expression squared equals 80 squared plus r squared. This expression is squared, meaning you have two of them. So put 50 plus r and another 50 plus r equals 6,400 is 80 squared plus r squared. This is FOIL method where you take first times first. 50 times 50 would give you 2,500. 50 times R would be 50R across the top. Now you go across the bottom, you'd get another 50R. And the last one, R times R, would give you R squared. What I would do next is combine 50 and 50 to get 100 R. So these two together, it's going to get you that 100R. So I'll scroll down here to make a little more room for myself. Okay, so next thing I would do is I would notice that you have R squared in there. That's your highest degree. Let's move that over to one side. What I'm going to do is I'm going to subtract R squared from this side and subtract R squared from this side. This will cancel, and it's very nice that this other one cancels too. Makes the problem a whole lot easier. So right now, we'd have 2,500 plus R equals 6,400. You'd subtract 2,500 from both sides, giving you 100R equals 3,900. If you divide by 100 on both sides, your radius is 39. So what's kind of cool about this problem is you could be on the outside. If it'd be full of grain, you couldn't go in and measure, so you'd have to use this, but this would be 39 feet if this would be in feet here, and this would be 39 feet, the radius for both of them. And then you can start solving things for like circumference of the grain bin and area of the grain bin, and then finding the height and then getting the volume of whatever you're storing inside there. Okay, and this is the last concept of the day, guys. This one here, a little bit easier. If you have a circle and two tangent lines, so here's your first tangent line. Remember, the definition of tangent is it hits the outside of the circle. And then you have another tangent line, but they both come to this point on the outside. The distance from the point on the outside to the point of tangency on both parts, they're just equal to each other. So go ahead and put that in your notes, guys. And the last problem of the day. Go ahead and put this guy in. So you have a point on the outside, two tangent lines. Those two tangent lines are equal to each other, so you'd have 28 equals 3x plus 4. Subtract 4 from both sides. Divide by 3, and x would equal 8. If you do need to rewatch this, it's on YouTube. If you go to Sargent Silbernagel on YouTube, and then G is for geometry, and this was section, I believe, 10.1. That's how you'll find it. Good luck on the assignment. Have a great day. And again, if you need to rewatch it, please go ahead and do so. And of course, I'm always available in the morning for tutoring. Have a great day, everyone.